Hi all, my name is Philip. Welcome to Chemistry Class Notes. Today we're going to look at, as usual, we're going to answer Jamb questions, for different years on basically atomic structures, shares, and orbitals. The first question: what type of bonding is? This is a complex compound, copper 2 tetraimine. We have coordinates, isovalent, metallic, covalent. The answer is coordinates. Coordinate is a type of covalent bonding. There's ordinary covalent and there's coordinate, covalent. For ordinary covalent, both of them has to do with sharing of electron pair. But for this ordinary covalent, only one of the both participating atoms they contribute the shared pair. But for coordinate, only one of the participating atoms contribute the shared pair. So the answer is coordinate. Then the next question. Elements P, Q, R, S have 6, 11, 15, 17 electrons respectively. Therefore, A. P will form an electrovalent bond with arrow. Q will form a covalent bond with S. Arrow will form an electrovalent bond with S. Then D. Q will form an electrovalent bond with S. First of all, we have to find out the particular element that is PQRS. So the one that has atomic number 6 is carbon. This is carbon. Q 11, that is sodium. Arrow 15, phosphorus. Then S 17, that is chlorine. From the atomic numbers. So P will form an electrovalent bond with arrow. That is P is carbon, arrow is phosphorus. Electrovalent? No, they are both non-metals. So B, Q will form a covalent bond with S. Q is sodium. Q is sodium. Then S is chlorine. Covalent bond. They don't form covalent bond. Then C, arrow will form an electrovalent bond with S. Arrow is phosphorus. Then S is chlorine. No, they are both non-metals. Then let's look at D. Q will form an electrovalent bond with S. Remember, Q is sodium and S is chlorine. So electrovalent bond has to do with transfer of electrons from a metal to a non-metal, right? And so the answer has to be D, sodium chloride, that will be formed, and that is an electrovalent bond. Next question. Which of the following types of bonding does not involve the formation of new substance? We have metallic, covalent, coordinate, electrovalent. Okay. The answer has to be metallic. For all these ones, they involve formation of new substance. But for metallic, there are forces that hold atom together in a metallic substance. So the answer is metallic bonding. It's metallic. Next question. The electron configuration of this a divalent ion, atomic number is 22, is we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. We have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d1. Then C, we have 1s2, 2s2, 2p6, 3s2, 3p6. Then D, we have 1s2, 2s2, 2p6, 3s2, 3p6, then 4p2. Okay, in this case, the atomic number is 22, right? But since this is a divalent ion, and this 2 plus, meaning it has lost 2 electrons. So we have to check the electronic configuration for the one that has atomic number of 20. But you have to subtract, since it has lost 2, you have to subtract 2 from 22 to have 20. So we're going to look for the one that has the, after counting the electron, it has to be 20. That will be the answer. So let's see. This is 12, 20, this one 20, 20. So it's 12, 18. Let's look at this one. This is 12, this is 20, 18. Okay, this should be the answer. This is 20. Remember, if there was no 2 plus, then the answer is going to be the one that has 22 electrons. But since it's 2 plus, you subtract the 2 from 22, and so the answer is the one that has electron number of 20. Then the next question. The shape of the s orbital is A, elliptical, B, spiral, C, circular, and D, spherical. Of course, the s orbital is spherical. The p orbital is dumbbell. D orbital, double dumbbell, then F, diffuse. But in this case, they're asking for the shape of s orbital. S orbital is spherical. Number 6. A particle that contains 9 protons, 10 neutrons, and 10 electrons is, we have A, positive ion, B, neutral atom of a metal, C, neutral atom of a non-metal, then D, negative ion. Remember, I said it has 9 protons, 10 neutrons, and 10 electrons. In that case, let's do something. So let's say it's X, it has 9 protons. That is the atomic number. So we do something like this. It has 9 protons, 10 neutrons. Let's say the mass number is going to be 19. And it has 10 electrons. So this is what you have been given. It has 9 protons, 10 neutrons. This is the mass number. 10 plus 9, 19. So it has 10 electrons. So in this case, it's an anion, because since they say it has 10 electrons, it has to be like this, because this one means it has gained 1 electron. So 1 plus 9 is 10. So this is what we're given. And I said the option said positive ion, neutral atom of a metal, neutral atom of non-metal, negative ion. So the answer is C, with D, negative ion. So the answer is C, D, negative ion. Then the next question. If the electron configuration of an element is 1s2, 2s2, 2p5, how many unpaired electrons are there? We have A, 2, B, 5, C, 1, and D, 4. Let's go over this. So remember, this is for number 7 question. 2p5. So this is the p orbital. It can accommodate a maximum of 6 electrons. Each of the shells can take a maximum of 2. So we said this we are looking for the unpaired electrons in its p shell. So we're going to fill them in. Remember, according to Hund's rule, they are filled singly before pairing. So I'll say 1, 2, 3, 4, 5. Meaning it has one unpaired electron, one unpaired shell. So the answer from that, the answer has to be, how many unpaired electrons are there? So the answer is C, 1. Then the next question. The nucleus of an atom contains A, protons only, B, neutrons, C, protons and neutrons, C, protons and electrons. Alright, the nucleus of an atom contains protons and neutrons. The electron is found outside the nucleus. So the answer is C. The nucleus contains protons and neutrons. Alright. Next question. Which of the following terms indicates the number of bonds that can be formed by an atom? We have A, oxidation number, valence, atomic number, electronegativity. So the answer is valence. Valence is electrons in the atom shell. It is that valence electron in the atom shell that is used by atoms in forming bonds. So the answer is B, valence. Then the next question. The number of electronic shell contained in an atom with electron configuration 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 4s2 is, so we are looking at the number of shells in this atom that has this electron configuration. From here now, the first shell contains 2, that's 1, first shell. Second shell contains 6, that is 8 electrons for second shell. Third shell contains 8, then the fourth shell contains 2. So we have 1, 2, 3, 4. So there are 4 shells. There are 4 shells. You can even see the number 1, 2, 3, 4, right? That is the principal quantum number. The answer is 4. Then the next question. Number 11. An isotope has an atomic number of 15 and a mass number of 31. The number of protons it contains is alright. We're given the atomic number as 15 and the mass number as 31. We are told to find the number of protons it contains. In this question, and this from 2011, 2016, at times Jamb questions normally repeat them. So let's read the question. We know that atomic number is the same as the number of proton. So once you know the atomic number, automatically you've known the number of protons. So in this question, we are given atomic number as 15. So since the atomic number is 15, that means the number of protons it contains will also be 15. So the answer of this question is B. Next question. Look at these two, atoms. The electron of two atoms, Y and Z, are arranged in shells as shown above. The bond formed between the atoms of Y and Z is ionic, covalent, dative, metallic. So from here, if you count the number of electrons, right? This 8, 9, 10, 11, 12. No, this one is 12. So 12 is magnesium. Atomic number of magnesium, 12. 12 electrons. Let's count the number of electrons here. This is 12, 13, 14, 15, 16, 17, 18. That's 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay, this is 14, right? This is 10, 11, 12, 13, 14. 14 is silicon. Sorry. 14 is silicon. Then this is 10, 11, 12, 13. Okay. This is silicon and this is chlorine. Silicon and chlorine. They are both non-metals. They are on the right side of the periodic table. And the electronegativity difference is low. And so the bonds that they can form is covalent bond. So the bond formed between the atoms of Y and Z, that is silicon and chlorine, is B, covalent. Then the next question. An element with atomic number 12 is likely to be dash. A. Electrovalent, the valency of 1. B. Electrovalent of the valency of 2. C. Covalent with the valency of 2. D. Covalent with the valency of 4. First off, let's do away with anything covalent, because atomic number 12 is magnesium, right? So it forms a electrovalent compound. So the answer should be between A and B. But let's look at it. Electrovalent with the valency of 1. Electrovalent with the valency of 2. So the answer has to be B. Magnesium is, is in group 2. And group 2, they have valency of 2. While group 1 has valency of 1. So like that. So the answer is B with the valency of 2. The diagram represents an atom of, because we have to count the number of electrons. So this is 10, 11, 12. Of course, first 20 element. The one that has 12 electrons, for neutral, this is a neutral atom, right? The one that has an atomic number of 12 is magnesium. So the answer is A, magnesium. How do we get A? Count the number of electrons here. It's 12. So the next question. The weakest attractive force that can be observed between two molecules is the weakest attractive force. The answer is van der Waals. The weakest attractive force that can be observed between two molecules. The answer is van der Waals. Not coordinate covalent, not covalent, not ionic. Van der Waals. Then, which of the following molecules is held together by a hydrogen bond? We have CH4, is methane, hydrogen bromide, Let's try to solve a cis acid hydrogen fluoride or hydrogen fluoride. So first of all, hydrogen bond is formed when hydrogen is attached to electronegative elements like fluorine, oxygen, and nitrogen. So in these examples, in this option, the only one that is attached to either fluorine, oxygen, nitrogen is D. So the answer of this question is D. Then the next question. The maximum number of electrons in L share of an atom is maximum number of electrons in the L share. First off, K, L, M, N. This is first share, second share, third share, fourth share. And the formula for calculating the maximum number of electrons in the share is 2n squared. So for L share 2, if we put 2 here, that is 2, 4. 4 times 4. Sorry. So 2 times 4, 2 times 2 is 4. Then 4 times 2. 4 times 2 is 8. So the maximum number of electrons in the L share is 8. The formula for calculating the maximum number of electrons in the share is 2n squared. We know that the first share is 1, K is 1, L 2, M 3, and N 4. So the answer is 8. So the answer is B, 8. Look at this question. The above orbital diagram shows the electronic configuration of, we just count the number of electrons. So this is 1, 2, 3, 4, 5, 6, 7. So of course 7 is nitrogen, right? You count it: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen has atomic number of 7 and 7 electrons. So the answer is B, nitrogen. The next question. If the difference in electronegativity of elements P and Q is 3.0, the bonds that will be formed between them is metallic, covalent, coordinate, ionic. Alright. Since the electronegativity difference, this is 3.0, this is high, right? Since it's very high, like this, so the answer has to be ionic or electrovalent. So the answer is D. Take note of the years for each of the Jamb question. I put the years. Alright, number 20. How many protons, neutrons, and electrons respectively are present in the element? This is cobalt. That's atomic number. This is 27. The mass number is 60. We are looking for protons, neutrons, and electrons. First of all, the proton is 27. Electron is 27. Then the neutron, you subtract the proton which is 27, from the mass number 60. When you do that, you get 33. So it has to be 27. The proton is 27. The neutron is 33. The electron is 27. So the answer has to be C. 27, 23, 33, 27. Remember, to get the neutron, you subtract the proton from the mass number. Subtract the proton from the mass number. So the answer is C. Next question. The electronic configuration of magnesium ion is 1s2, 2s2, 2p6, 3s2, 3p2, B, 1s2, 2s2, 2p6, C, 1s2, 2s2, 2p6, 3s2, D, 1s2, 2s2, 2p4. Remember, since this is not a neutral atom, this is a magnesium ion. And magnesium has atom number of 12. So since this is an ion, meaning it has lost 2 electrons, so we subtract these 2 now from 12, giving us 10 electrons. So we're going to look for the one that has 10 electrons, right? So let's see, 4, 5, no. Okay, look at this one, 6, 7, 8, 9, 10. So the answer is B, because it's a magnesium ion and is it has lost 2 electrons. That's why I have to subtract 2 from 12. If there was no 2 plus, if it was just magnesium, that means we have to look for the one that has 12 electrons. But since it has lost 2 by this sign here, 2 plus, meaning you must subtract what is here from the atomic number of the atom. In this case, 12. So 12 minus 2, you get 10. So that is why the answer is B. Then the next question. If the elements X and Y have atomic numbers 11 and 17 respectively, what type of bonding can they form? Dative, covalent, ionic, metallic. First of all, I said 11 and 17. 11, atomic number of 11, that is sodium. Then the Y, the one that has the number of Y, that is 17. 17 is chlorine. So of course, the bond that is formed between sodium and chlorine has to be ionic. So the answer is ionic. Sodium is a metal, chlorine is a non-metal. Ionic bonds, that's to do with transfer of electrons from a metal to a non-metal. Because sodium, wants to get rid of this electron, and chlorine wants to accept. So they form an ionic bond. So the answer is D. Next question. A hydrogen atom which has lost an electron contains dash 1 proton only, 1 neutron only, 1 proton and 1 neutron, 1 proton, 1 electron and 1 neutron. Okay. When the hydrogen atom has lost an electron, since it has lost an electron, it will only contain 1 proton, not 1 neutron, not 1 proton and 1 neutron, or this other one. So when hydrogen has lost an electron, it contains 1 proton. So the answer is A. Then the next question. The molecular lattice of iodine is held together by, we have dative bond, metallic bond, hydrogen bond, van der Waals forces. So the answer of this question has to be van der Waals forces. Though van der Waals, they are weak, bond or forces. So the next question: how many unpaired electrons are there in nitrogen sublevels? A, we have 3, B, we have 2, C, we have 1, D, we have none. So let's illustrate this. Nitrogen has atomic number of 7. That's 1s2, 2s2, 2p, 2p3. So we are looking for how many unpaired electrons, right? So this is 3, so 1, 2, 3. So for me, we can see that it has 1, 2, 3 unpaired electrons. So how many unpaired electrons are there in nitrogen sublevels? So the answer has to be A, 3. When ammonia and hydrogen ion bond together to form ion, the bond formed is called, we have electrovalent bond, covalent bond, ionic bond, then covalent bond. Alright, this question: when ammonia and hydrogen ion bond together to form an ion, the bond formed is called dash. Of course, the answer is coordinate bond. So in this bonding, the ammonia has a lone pair of electron that it donates to the hydrogen ion that doesn't have, right? That is coordinate. Thereby the shared pair is contributed by one of the participating compound. So the answer of this question is coordinate, not covalent. Then the next question: which quantum divides shares into orbitals? Spin, principal, azimuthal, magnetic. The answer is azimuthal quantum number. They divide shares into orbital. And again, they also determine the shape of the orbital, azimuthal quantum number. So the answer is C. Then the next question: how many electrons will be found in the nucleus of an atom with mass number 23 and 17 neutrons? Okay, this question, take note, all these are 2019 Jamb chemistry Jamb past question. For this particular question, it's always advisable to read your question well before answering it, because you might be forced to be doing small calculation to subtract some things from the other, because they mention electrons. How many electrons we found, right, in the nucleus of an atom with mass number 23 and 17 neutrons. Take note, electrons, nucleus. Electrons is not found in the nucleus, right? You don't need to calculate anything. Don't wrap your head about it. Just know it is only protons and neutrons that are found in the nucleus. Electron is not found in the nucleus. So this kind of question, they are telling you how many electrons will be found in the nucleus of an atom with mass number 23 and 17 neutrons. The answer has to be A, none, because electrons are not found in the nucleus. Take note, read your question well. Second to the last question. Hydrogen bond is a sort of A, van der Waals force, dative bond, ionic bond, covalent bond. Hydrogen bond is a sort of, the answer is van der Waals forces, right? Hydrogen bond is a type of dipole-dipole interaction. That is an example of van der Waals forces. So the answer is A, van der Waals forces. Then the last question. The electronic configuration of element Z is 1s2, 2s2, 2p6, 3s2, 3p1. What is the formula of the compound formed between Z and tetraoxosulfate 4 ion? We have A, Z3SO4, in bracket 2, B, ZSO4, C, Z2SO4, and D, Z2 bracket SO4 3. So I want to look at what will be formed with this compound that has this atomic number, this electron configuration with SO4 2 minus ion. So this is 1, 2, 3, 4, 5, 6, 7. That's 13. 13 is aluminium. So let's do something. So 13 is aluminium, right? You said Z and SO4. This is a radical. It has a valency of 2. I want to put it here. Since Z is 13 is aluminum, right? Aluminum is a group 3. That's valency of 3. So I'm going to put that here. So we just now have to, cross multiply those like this and like this. So at the end of the day, we have something like this: Z2 SO4 bracket 3. So this is what will be formed. 2, the valency for tetraoxosulfate 6 ion. Then 3, valency for Z, aluminum is in group 3. That's 13 electrons. So cross multiply, so you get this is what will be formed: Z2 bracket SO4 3. So the answer has to be D, Z2 SO4 3. Okay, that is the end of the video. Remember, these are past questions in chemistry for Jamb. This video is also beneficial to people who be writing waec, g.c.e and the likes, depending on the exam you want to write. You also have to go through them. So these questions are a collection of Jamb questions from chemical bonding, atomic structure, orbitals, shell, and a little of quantum number. So if you enjoyed the video, you can leave a like and subscribe. The next video, we're going to be answering questions, of course, as usual, past chemistry Jamb questions on periodic table. So thank you.